works. We started the company in 2014, and we moved the company to Singapore in 2016. I'm the CTO, so running all the technical stuff. Usually, Pavel and I split up these sorts of duties. Today, I'm trying to be more technical. So, can I use this connection?
Go nuts.
So, what, Bluzelle. We're building a product called Bluzelle. And what is it? It's a decentralized, on-demand, scalable database. As a tech pioneer in 2017 from the World Economic Forum. And we also made it to the Global FinTech 100 list. We've built a KYC shared ledger for a consortium of international banks. We've also built a smart insurance product for an insurance company in Southeast Asia. And we did a proof of concept cross-border payments POC for Tokenomics, which is a core banking system based out of Luxembourg. They're used in a lot of banks all over the world. So the decentralized internet, most of you probably already understand that given we're at Ethereum Meetup. The way we're looking at it, it's going to be an ecosystem that's going to have applications. A lot of you probably tried to get status a month or two ago when Ethereum crashed. I tried to as well. So it's the application sitting on top of several different pieces that developers would need. You would need an operating environment such as Ethereum where you can run a Turing complete smart contract, some sort of file storage mechanism like Filecoin. And the other big piece that's important is a data storage mechanism, so a database. That piece is missing. Bluzelle is that piece. So we look at ourselves as the oracle of the internet. So the past model, present model, future model. Past model, with a database, you had your application running, and your database runtime, cache, all of that was on one machine. If something went down anywhere in there, your whole system was down. Present model with the cloud computing model, you've got a cloud, you've got AWS, Microsoft, or Amazon S3, got a load balancer, you've got your zones. Yeah, if one of your zones goes down, you're probably okay, except if somebody breaks in and wants to steal your data, they just have to breach the load balancer and get onto one of your machines, they get all your data. If they want to corrupt your data, they can do the same thing, it's going to get mirrored. They can do all those sorts of nasty things. If Amazon goes down, which doesn't happen often, but if it does, you're hooked as well. My company was affected by that at some point 6 months ago when Amazon did go down, and it caused hysteria on the internet. The future, which is the rightmost one, is where your application, using the same interfaces, is now talking to a swarm. It's actually a swarm of swarms. So that's what Bluzelle is up here. It's a meta swarm. Each of these little icons here represents a swarm, and what is a swarm? They're nodes. It's a collection, it's a little mini network. Except it's not that many. You could have thousands of nodes in each swarm, and each swarm is replicating your data. So imagine you now have a two-column table. Let me see if I can add to it. Imagine you have this two-column table. It's a key value pair database, and there's two columns, and you want to store that data out on the database. Well, traditionally, the data would be stored in one place. Now what's happening is actually being sharded, horizontally partitioned. So in this case, I'm showing an example where the first two rows get into one of the swarms, third row gets into another swarm, last three rows get into the third swarm. Simple example, and we're using a hashing function to determine which bucket or which swarm your data gets into. One of the nice things about it for developers is if the number of swarms changes, the amount of data that moves is very minimal. We're using something called jump consistent hashing. So basically, if your number of swarms is n, and n changes to n plus 1, for example, the amount of data that gets moved is actually 1 over n. So it's quite small. And that actually, if you do the math, as the number of swarms go up, the amount of data moving is reduced. So, what are the three areas we're addressing? Performance, reliability, scalability. By the way, I don't want to keep going. Maybe there's some questions right now before I continue. Any questions so far?
It's an open floor, so
yes.
Speak up.
Try to keep this interactive.
Yeah, so maybe the stack you had showed in the beginning,
Yep.
where you were below Filecoin.
Yep.
Because like for me, Filecoin is just like a storage layer for all kind of data, and then you would use, like if you want like SQL queries on that data that's in Filecoin, you would have like some mechanism that takes that data and does the computation on it and returns something. So what is it that you provide in that context?
So first of all, I apologize if this is kind of showing some sort of dimension here. It's not like we're sitting under Filecoin or anything.
Okay.
We would actually be sitting alongside of them. So that's a good point. Maybe we should change this diagram a bit. But basically, we would be one of the pieces that are sitting in this ecosystem. So if you're running an application, some sort of whatever, you're running a game, for example, you're going to need a file store, maybe to store avatars, people's images. You're also going to need a place to maybe store people's scores or any kind of other information that's more structured information, not files. So you wouldn't want to use a file store for that. You would want to have some sort of database where you can do queries, aggregations.
Yeah,
all
I
those
mean,
things.
Filecoin is not like file storage. It's more like any kind of data. You just put it in a JSON format and store it.
Correct. So we're really positioning ourselves as a database, an actual database.
Yeah.
That's the difference here. So, any other questions?
But you provide like queries and stuff
Yeah,
like that.
you can basically do NoSQL queries on a key value pair, and then we're going to be expanding it out in a future version to support documents, collections, partitions, all the stuff that you expect from a NoSQL database. Yeah. But one of the key aspects that's interesting about our product, which people ask, is encryption and security. Your data is encrypted the moment it leaves your machine. It's never traveling around in plain text on the network. So you can still do queries on that. There's actually a way to do database queries even though the data is encrypted. It basically is a modified form of encryption. I'm not an expert on it. We have an advisor that does this. But it basically allows you to basically get down to what you can compare A and B. Even though they're both encrypted, there's still an ordering. So you can still say A is greater than B, A is less than B, A equals B. So it allows you to still do all your queries, but still keeping all the data protected.
Maybe I get that, but I mean, like Filecoin, there's an idea of this, that it's kind of decentralized in a way that anybody can run their node and just connect to the network.
Yes.
But your servers or your nodes, where anybody really incentivize people to run like Bluzelle nodes,
Right.
where you're not going to have like a cluster of.
Sorry, I skipped ahead. So yeah, Bluzelle's driven by a token, and that's why we opened with the fact that we're doing a token generating event in late October. The tokens drive the crypto economy, so it is a utility token. It's very vital to have the token in order to drive this whole crypto economy. So you have producers or farmers and consumers. The producers, which are the nodes participating in this, in the swarms, they are incentivized to participate because they're earning tokens. And the cost of using the network is determined by the network. So if you're a consumer going in, doing create, read, update, or delete, which are the 4 key functions of the database, you have to pay accordingly. And there's different service levels. For example, you can do the same things like edge caching, where if you're in Stockholm or Gothenburg and you want all your data to be close to you, you can have it cached in nodes close to you, on swarms close to you, so that the speed, the latency of getting your data is lower, but you pay more for it. Things like that. So there's going to be different models. The initial MVP that we're going to be doing in April, which is our beta, is going to be pretty simple, and it's going to go out from there with different service levels and redundancy. So it's all in our white paper. Any questions?
Is there any superficial or surface level similarity or inspiration from something like Riak?
Which one?
Riak, the database?
Oh, React?
Riak, R-I-A-K.
I'm not familiar with it.
I think sort of uses a ringed data structure to sort of distribute data.
Oh,
across
you're talking about
nodes.
the consistent hashing?
Yeah, I mean, yeah, exactly, yeah.
That's interesting you bring that up. So we actually looked at that form of consistent hashing to determine where the data gets stored, so that if you change your buckets or you want to know where the data is, you can locate it. It's a data location service, basically.
Okay.
The problem with that model that you just talked about is the state machine, in order to store where the data is, starts to grow to the point where it could actually overwhelm the amount of data being stored itself. There's a massive state machine, and the amount of transitions, the amount of data required to maintain that state machine is huge. So we're using a different thing called jump consistent hashing, which you can read about. It's a white paper, readily available on the internet. It allows you to do much of the same thing, but the distribution of data is much more uniform across all the buckets. And like I said, if you change the number of swarms, it stays much more, the amount of data moving is minimized.
So tunable cap, basically, is what you're hinting at.
If you mean by tunable number of buckets, yes.
I mean, it's definitely partition tolerant, but you're talking about basically the consistency and availability being tunable.
Yes.
The sort of balance between the two, kind of like.
Right. I mean, one of the key things is ensuring that when we say performance here, a lot of people wonder, is the performance better than if you were running a massive database in your local area network? No. The real thing here is performance is consistent. So, suddenly if you have a spike in demand, your performance is going to stay consistent. I don't know if any of you watch boxing. They had the big fight in the United States this past week. I didn't watch it. A good majority of the servers providing streaming data crashed. They weren't prepared for the demand. So scalability is a major issue. Providing performance, especially when you have those big spikes, is an issue. So one of the key things we're focusing on here is making sure that the network can adapt when there are high demands. So if a swarm suddenly gets a spike in demand, it'll be able to handle it, or it'll be able to cache the data closer to where the demand is coming in. And going on the on the note of reliability, your data is not in one place. A lot of people ask, where's your data? Well, it's not in one place. It's stored all over the place. If you look at a lot of the other decentralized models, same thing. Your data is chopped up. So if somebody breaks in and gets to one of the swarms, A, they may not find any of your data because your data may not be on that swarm. But B, if they do find your data, it's only a part of your data. Your data is spread out all over the place. So, and C, it's encrypted, and it's also got a signature attached to it. So even if they change it, it's going to get detected. They're not going to be able to change all your data because they're only going to get part of it. And they don't know where the rest of your data is because the location service is also obfuscated. So there's no way to actually get a list of where all the swarms are, where all the data is, unless you are the owner of the data.
One question, like you said that the data is there in different locations.
Yes.
And if somebody is hacked and you can't take the information from every swarm, right?
Mm-hmm.
But isn't give performance issues like to get the data from each and every swarm, and when I require some type of a data, it is actually contacting a different databases, you can say, because you have actually accumulated the databases in different locations. So rather than connecting to a single database, I am actually connecting to a several database which is present in a different location. So isn't it cause some performance issues on that part, like rather than getting the information on that part?
Yeah, that's a good question. I mean, one thing that comes up that's a little confusing is the swarm. A lot of people think the swarms are located geographically located. So, for example, one swarm might be only in North America, and then one swarm is in Europe. It's not like that. The swarms are actually agnostic to location. So, for example, if your data is spread over, say, 10 different swarms, once this reaches critical mass, you're going to have nodes that are actually quite close to you, and you can actually parallelize the requests. So it's actually not that you have to go and make 10 separate requests to nodes that can be all over the place. It'll actually be quite localized. But like I said, we're not claiming here that this is going to be faster than going and grabbing 1,000 rows from a data sitting on your network. But the performance is going to be
But how much of performance
that's a good question. We don't have specific metrics on that. We are looking, we're talking to people at storage, for example, and they've already done metrics. And their cost, I believe, is about half of what cloud computing is, and their speed is comparable, I believe. I don't have those figures in front of me, but it's not. You're not really taking a huge hit when you're going to those guys. So it's a good question. But if you need like 10 nanosecond latency, well, it's a special use case. It depends on what you're doing. For most of the time, as a developer, we build enterprise applications. We're fine with it. The main thing for us is having consistency, making sure things keep running. Any other questions?
So I was just wondering if the data is traded among the other agents.
Sorry?
Is the data traded among the other agents?
What do you mean by traded?
Is it when I do like storage, I store to one node only, and I pick from that node only. That data never leaves that node. Or
Is that true for storage? Okay.
I don't know.
Well, basically, I'll give you our model, and I'll jump ahead to one of my really developer-friendly slides here. Yeah, here. So we're using a consensus model. It's not quite Raft, but something similar to Raft. And what it means is just look at my beautiful diagram of the swarm up there. You've got a bunch of nodes, and then you've got a leader node. So that's where the consensus is happening. And really, all those nodes have the data, and you can actually talk to any of those nodes to get your data. So it's not just one node. We're actually distributing it out. And in fact, when you make a request to a swarm to give me my data or do whatever, multiple nodes can compete. So they can parallelize the request, and the fastest one would come back, give you the answer. And the reward mechanism would be distributed accordingly to reward the node that comes back the fastest. So there is an incentivization for nodes to respond faster, provide better hardware. They just get better remuneration for it. Does that answer your question?
Yeah.
All right. Any more? Continue. So yeah, the 3 key technology highlights we're doing here are swarming, which is a little different from just having nodes directly. One of the reasons we chose to do swarms and kind of abstract away the concept of a physical node is you can't deal with nodes going up and down. I mean, you want to really have the concept of a swarm, so that if you have a swarm with end nodes in it, and some nodes go down, some go up, it doesn't affect the swarm continues. And that's really important, keeping the number of swarms static as much as possible. Consensus is obviously very important to make sure that data is consistent, there's no, you don't lose integrity, and then we do partitioning. Our initial version is just going to be horizontal partitioning, eventually we're planning to do vertical partitioning as well. Okay, so this,
Vertical partitioning is like on the same?
yeah, column families.
Column.
Yeah, column families, exactly. So, you know, just for the rest of the people, vertical partitioning, which I was not super familiar with, is, let's just say I'm storing information on citizens of Sweden, and you know, the key information might be your taxpayer ID, your first name, your last name, your date of birth. Lesser important information might be what kind of car do you drive, what's your driver's license number, what's your dog's name. That information may not be so important, so that might be actually sharded out separately in data and stored out with less replication, or in nodes that are in swarms that are further off, things like that. So we have 2D partitioning where we can actually do things splitting up the rows, but we can also chop up the column families themselves. So that gives you a higher level of granularity in terms of performance. And of course, there's higher service level. If you want to cache only certain columns, you can do that. So that's something we're going to be building. Kademlia hashing, this is one of my favorites. It's, for some of the computer scientists in here, it's not exactly Kademlia, I've kind of simplified it a bit, but basically, a lot of people ask us, how does data get located? I mean, let's just say there's 10 million swarms out there. How do you find your data? Do you actually know about every other swarm? No. So if you go to a given swarm, like let's just say we go to swarm alpha, which I listed out there in blue, how does swarm alpha know about swarm golf? Golf is not even listed in there. Look at that address table. We've got swarm Bravo, Charlie, Delta, Echo, and Fox listed in there, but golf is not in there. So let's say that swarm alpha needs to find all your data, but it's on swarm golf. How is it going to do that? Well, it uses this address table. It can go in and it can say, well, swarm golf is in swarm Fox's neighborhood. So I'm going to talk to swarm Fox, and I'm going to say, swarm Fox, give me where's golf. Swarm Fox has its own address table, and it is actually closer to swarm golf than you are. So you're going to get exponentially closer to your destination every time you do a redirect. And if you actually do the math, the computational complexity is logarithmic. So even if you had, in an extreme case, 4 billion nodes or swarms, which is 34 bits of address space, you would have at maximum log base 2 of that, which is about 34 redirects, on average 17. So it's, and of course that's an extreme case. I can only wish we have 4 billion swarms in some case. Any questions on this? Okay, so here's another one. Since this is an Ethereum meetup, we'll talk a little bit about our token. So the token sale we're going to be doing is for the BLZ or BLZ token. Is it Z or Z in Sweden?
Zeta.
Okay, Zeta. Okay, so BLZ. Okay, so our BLZ token is an ERC20 token that's going to be driven by a smart contract. We're doing this in the 4th quarter. And we're not using the token directly in our network that you see below. So the top is Ethereum, the bottom is Bluzelle network. The reason we're doing that is twofold. One of the reasons is you don't really want to be waiting for block confirmations every time you're doing a transaction. Let's say you're paying for a create or a read or update or delete or whatever. You don't want to wait for Ethereum to actually confirm that block before I pay you, before I get my request fulfilled. The other reason is you don't want to be dealing with the mining fees. Every time you send out an Ethereum transaction, there's a fee. It may not seem very large, but if you're writing an application that's database intensive, or even if it's not, that can add up pretty quickly. It doesn't make any sense. So what we actually have internally is the BNT token, which is the Bluzelle native token, and it's internal only to our network. It does not exist on Ethereum, but it is exchangeable for BLZ using a smart contract. So in order to use our network, it's very simple. You use BLZ token, and then you just get BNT tokens, and you can use our network. It's, it allows us to basically have high-speed transactions, whatever you would expect from a database, while still being tied up to Ethereum where you have your actual value store. And BLZ will be exchangeable on exchanges just like any other ERC20 token. Any questions?
Yeah.
Yep.
So how do you prevent double spends?
Great question. Somebody always asks that. We're considering several possibilities. One of the ones we're considering is using Ripple. Not directly, but using a decentralized consensus ledger. Part of the reason is Bluzelle's core team, we have been using Ripple since 2014. We forked the network. We're very good with it. We wouldn't be using the full-blown protocol. We'd be using a part of it that basically propagates the internal token. One of the things we're considering about it is possibility for Sybil attacks and ensuring that that doesn't happen. There's some issues with validators which we're trying to sort out. One of the other possibilities we're doing is using a proof of stake internally. The key thing here, though, is making sure that whatever database we're using to propagate the BNT token does not grow without bounds. That's really important, an important property of our network.
So is the reason you couldn't use like state channels?
Sorry, which one?
The payment channels.
Can you elaborate on that?
So like for Bitcoin it's called Lightning Network, for Ethereum it's called Raiden Network.
Okay.
It's basically a second tier layer which you put on top of the blockchain, and you open channels where you can make micropayments.
Mm-hmm.
You make one initial transaction, then you can like create a network where you can pay anyone who's in that mesh through channels of open. You can create channels between peers and make microtransactions with only with the security of the blockchain, but you don't need to submit all data to the blockchain.
Got it. Okay. Well, that's something we're looking into. I mean, that's one of the areas that's still open for us. So we're considering different aspects. We're currently talking to our internal contacts at Ripple, and we've got some people on the Ethereum board that we're talking to, because that's obviously very important to making sure that the BNT token is secured. So thank you for that. Any other questions? A little bit of background about us. So my CEO, Pavel Baines, has operated 7 Disney studios across 4 continents, and is an alumni from 500 startups. He's also a UCLA alumni. Myself, I worked with Google building retail-friendly versions of the Android operating system. Retail-friendly simply means, to those who are curious, it means I can't walk into a store and do nasty stuff with the phone that's on demo. And I'll leave you to figure out what nasty stuff means. Lufthansa built in-flight entertainment systems. And for those of you who've used ZeroBlock or heard about it, I was the 4th person at ZeroBlock, so I built the Android version of it, and it got acquired by blockchain.info in 2014.
Congratulations.
Thank you. They paid me in Bitcoin.
Oh, you did? All right.
Which, the next question is, when did you get paid in 2014?
Yeah, exactly.
I can tell you I got paid when it was at $1,200.
That's good.
No, because I didn't sell it. It's good now because I still haven't sold it. So our team is very heavy on just computer science background, a lot of machine learning, blockchain security, AI, and cognitive science background. And in closing, we have 5 touch points. I would definitely love for every person in this room who's interested to get involved with our Slack community group. We've already got, I'm going to show a simulator after this, but we have a Slack group, so you can go on there immediately and get involved. We have an email list at bluzelle.com. We have Twitter. We're on GitHub. You can already download the simulator code. It's all C++, but if you know CMake, it's very easy to build it. You don't actually have to use C++ to build it. And then we have a Medium blog, which is quite active and it's growing. Yeah. Any questions before I go to the simulator?
Who are your potential dream customers? I mean, who sort of you'd love to have on your platform, like to sell to, basically? Enterprise?
No. You know what? There's no people in enterprise here, is there? Okay.
I don't know.
Okay. Well, personally, I'd like to get startup developers. You know, people that are building indie games, apps, mobile apps, indie developers, startup developers involved. I mean, that's really where my passion is, and that's where I feel the pain. I have a startup developer background, and I really see them being the first ones. Enterprises, there's a huge amount of friction. I mean, we build stuff for banks, and it's actually pretty hard. There's lots of legal and regulatory that you have to go through, and we did crack that nut, but it's difficult. So I definitely see this as really immediately helping the startup developers, the smaller company developers, small businesses, and it's going to go from there. I mean, bigger businesses also can benefit from it.
So you get asked a lot about, I mean, since you'll be competing with the existing paradigm, which would be cloud-hosted databases.
Yes.
So do you get asked a lot about what the locking situation is, as in potentially?
Not really, it hasn't come up. I mean, one of the things that I should mention is this database, the interface for it as a developer is not a blockchain interface. You don't have to be a blockchain developer or understand Ethereum or Bitcoin or anything of that to use it. Where the interface, as far as the developer is concerned, is create, read, update, delete. There might be small changes from a normal database interface, but our goal here is, you know, most of the developers I know in Silicon Valley don't know blockchain. They're actually very good at Android, they're very good at iOS, they're very good at whatever they do. Some of them build Xbox games. They don't know how to use blockchain, and we want them to be able to use it. So the interfaces that they're going to have allow them to transition whatever they may already have or what they're building to use this. They don't have to understand the blockchain concepts to use this. So the target market is a developer that needs databases, plain and simple.
Do you have any client libraries there?
In process. You can look at the white paper though to see what we're going to be building. We've got a huge section on the API. The white paper, just so you know, we have a primer, which is more of a business-friendly thing, which is pretty short. I can't remember. I think it's 14 or 15 pages. We have a public white paper, which is about 40 pages, which includes a bit of technical depth. We have the technical white paper, which is about 80 or 90 pages. So, you know, choose your poison, whichever one you want to go into. It goes pretty deep if you want to read into it. And I will now get into the simulator. Let's see here. All right. It's kind of a small screen, but basically what we're showing here is a simulator of nodes on a swarm. And what we're trying to show here, and right now it's just what we're actually doing, you'll see thread there. So we're simulating nodes as threads. So instead of going out and just building this out initially, our first stab at this is we're having threads running in memory, and each thread is acting like a node. So each thread has its own state machine, and it's simulating what a node would ultimately have. And what we're actually doing is deliberately giving a probability each node of crashing. And you'll see that from time to time that there's nodes that are crashing, and this list is actually changing here, this node list. Some nodes are coming up, some are going down. And what we're going to show here really is that your data can go into here and it'll get persisted on a swarm irrespective of what's going on with the nodes. So the first thing we're going to actually be doing is connecting an API up to this. And you'll be able to write an application, and you'll be able to see your data getting stored out onto these swarms. And you'll see your data being stored. You can click on nodes, you can kill nodes, all that stuff, and see this stuff in action. And this is going to follow an agile process, turn into the actual product. But we want people to be involved, be able to see what's going on, participate. The product itself is on the GitHub, so you can take a look at it. And we're currently talking to Richard Stallman about figuring out the right license for this. In fact, we're trying to get him as an advisor. So if anybody knows him personally, come talk to him. Any questions on the simulator? Okay, great. Couple more things before we end, or I end. I have some stickers on my computer. My CEO insisted that I mention I have stickers, so if anybody wants stickers, please. And there's another sticker that's kind of cool. This one here, this is our logo. It's very nice. And I didn't announce it before, but I'm getting t-shirts out to 3 people who asked good, challenging questions. Let's see. You, sir? I have 2 larges and 1 medium.
I'll leave it out.
Okay. And one caveat is I'm going to need everyone who's getting one of these shirts to stand up in the front and get a picture. Is that okay?
Awesome.
And let's see, you were over there, medium or large? Okay. That's this one here. see. You, sir. You get the large.
Thank you.
Yes.
Thank you so much. Well, I know you have to be going back to Stockholm, right?
Yes, I'm jumping on a train. Oh boy.
Yeah.
Okay, I gotta leave like in 2 minutes.
Okay. Is there anybody going to Central Station so we can give this good gentleman a ride? Nobody.